Hello and welcome back. It is Fluke Friday, and on the Fluke Friday, I show every time a different series from Fluke. And I started from the lower number, so I've got the 7, I've got the 10, I did the 25, and now we are in the 30 series. Little disclaimer, this video is not sponsored by Fluke. These items are not original, but I made this for the purpose of this video because I'm a fan and of course because of the copyright. It will not be for sale. So the 30 series. I like to show first the 30 and the 32. They are clamp multimeters. And we're going to play with it a little bit in practice to see, because I think it is only AC, so I will need to do some tricks, and I'm not sure I can do this 200 or 400 amps. Well, I'm pretty sure I cannot do that, but maybe it can still have a readout also on the lower current, so I'm going to play with that. Maybe if you have a good eye, you also see the 37. That one will be for next time. The Fluke 30 here and the Fluke 32 here, both bought second hand. This one actually looks quite good. Battery even works. Yeah, with this bag even comes with probe for the lower currents. I think you can use the probe now only for voltage and for ohms. You use the probes, and this one you can see it is kind of dirty. I also bought it as new, but this is really in a less good state as the other one. And the back, it's kind of, I noticed from all the Fluke bags from the gray type, the smaller, this is a bigger one, the smaller one, it kind of starts to degrade. Yeah, it's terrible what I did. It is sticky. So yeah, I don't know what to do with this. Maybe someone knows how to clean this or restore it, or you just need to throw it, or maybe you just take the whole inside out and then only keep the plastic. Maybe you guys have some tips for me for this. So they are actually quite big, and yeah, for scale they look the same, but I have here a little Chinese one. Well, you can see it is a huge difference between the two, and both can do high currents, but of course there is also a quality difference. This one goes up to how many? 100 amps. Oh yeah, that's a huge difference. This one goes a little bit higher. Yeah, what is now the real difference between the two? Because they look very similar. Hold button, 200 amps, 600. So the 32 can go to 600, 200 ohms, 200 volts, 600 volts, and through RMS. So that's the only difference. Then let's get the specs. I did find the flyer. And the 30 and the 32 are just mentioned on the same flyer. It's very strong, industrial, hospitals, blah blah blah. You can drop from 2 meters. Why would you want to do that? They have a Cat 3 600 volt rating. Very nice. Yeah, and the difference between the 30 and the 32 was indeed the true RMS and the higher amps, the 600 instead of 400. True RMS has a crest factor even, and the crest, I think that is how well it can cope with distortions on the signal it's measuring. And on the 600 amp setting, it can handle 3 and below, and on the 400 is 2 and below. And there is no mention of a crest with a non-true RMS, and they both have 2000 counts. Well, let's start playing. Well, they can only do AC voltage, and the lowest is 200 volt with 2000 counts. So let's see how precise we could see a few volts here, and we can do the same for both. And this one needs a new battery. Well, nice opportunity immediately to see how to replace the battery. It seems that there is one little door here, one screw. I hope it's 9 volts. It is. They put inside of a Duracell industrial. Well, it did not leak. Okay, that needed a little bit more force. I thought it would be leaking. I did leak a little bit. I clean it first a little bit. So first I will just try the 5 volts from my DMM Check Plus, because it's my only device that is AC, but it is a square wave, so it will do a little bit more, like 10%. And let's see if it can even measure 5 volts. Okay, so what is switched on? I don't have too many digits, so it doesn't matter too much for the DMM Check Plus. It is on AC first setting, so that would be 100 Hertz. So the lowest here is 200, 200, and this is through RMS, so this one should be able to handle the square wave. So this one probably will say 5.5, and this one will say, yeah, it should say 5. So let's try this on, yeah, 5.4 volts, and I can try also 10K. Then it says 2.8. Well, that's expected. And this one should do better. This one should actually say it's 5. It's through RMS. Yes. Here it is. And what about if I put 10K plus instead of 100 Hertz? Here we go. No. Maybe that is the filter that is in there, that it will try to filter out all these high peaks because of his crest rating. Okay. Well, I do have an AC source, so I can do, let's say, 200 volts or something. Let's start this. And this one is a perfect sine wave, so both of them should just say exactly the same. I can try to do a little bit more with the frequency. I can do 45 Hz up to 500 Hz. It's the Matrix APS 7100. And well, I wanted to have it because just to have some AC sort of power supply. It can do a kilowatt. So well, I will put it on 200 volts. There are some wires in between, but let's say VZ. It's now on 300. Oh, let's put 300. Why not? 350 Hertz, and then output on off. Let's connect it. Okay, well, we need to put it to the 600 volt setting, and it thinks it's a little bit more, 302. It is on 50 Hertz and 300 volts. I will just switch it over. Be careful not to touch it too much because it's 300 volts. But this one thinks it is closer, but this one has fallen a lot. Let's see what it is if I put it here. Well, the AC power source is good. It should just say 300 or 301. Okay, yeah, it really thinks it is more. So maybe we can adjust that. Okay, can see later. I don't see it's 2000 counts as it said, because I never seen a higher value. What if I put 150 volts in the other scale and maybe we get that extra digit? Okay, output off, VZ. Maybe I can just. There's probably a better way, but I don't use it too much. So we'll just do it like this. $160, and then we can switch it over to the other. Yeah, it agrees sort of with 160. It's probably just too high also. But now we should be able to go also to the other setting. And do we now get that extra digit? Yes, we have. And now let's try that on this one. Yes. It can also measure ohms, and I have here on the TMM Check Plus, I have 100 ohm in a K. Well, 1K is not gonna work. So I can do maybe, I can use this one with the emulated ohms. Okay, well, let's see in the ohms. Not sure you can read the display, I don't think you can. Like this. It even beeps. 0 ohms. Okay, let me get the 100 ohm. Yes, 100. Okay, maybe we can play a little bit with this one. I think it starts beeping at 60. So it should still beep. No, it doesn't like the emulated ohms. Okay, that happens sometimes. Then the impedance is probably different. Let's see here. How is this one? Also beeping, still works. What about 100? Yes, here the ohms is a little bit low. Okay, that's all nice, those things work, but we actually want to measure current because that's what it is for. And I hope I see some current because I don't have an AC electronic load. But what I can do, I can put the power supply, I put my DC electronic load on that, and I can measure maybe on the AC side. It will maybe only be 1 or 2 amps, but if we can see that, that is good. Also, if I would get a water heater or something, then I could maybe measure 5 to 10 amps, but I don't like water here in my lab, so it will be my power supply. So big power supply here, it can deliver about 35 amps on the DC 13 volts. So I would see a few amps. My electronic load there. So I connect those, and then I can try to measure on the AC part if we can see something happen, and I can get my older measurement here also, so we can check the current. I will put that just in between, so we have some reference for the clamps. I will just put it in here, put the power plug in here. That is the AC side. If I switch it on, okay, this will go to the power supply. Then my electronic load goes in here, and we can see that it is already using 10 milliamps. I don't think we will see that on the clamp multimeters because they are for such a high power. But what if I put some load? I put now 4 amps on the DC side, and that means we have here 430 milliamps on the AC side. So let's go to more or less 1 amp and see if we can do that. Okay, about 1 amp, The maximum is 10 amp on my DC side, but that's okay. 1 amp on the AC side. Well, the thing is with the Clampmeter, you cannot just measure on the cable like this. Okay, I'm running this now for a while, 10 amps, and my cables don't get warm. My electronic load is not making noise, so that's all good. And still we are having 10 amps here. Pretty cool. But measuring here on the incoming AC power line will probably not work like this, because we have the positive and the negative wire here. So that means that will cancel each other out. And so what we need to measure on 1. So that means I need to open the cable and just measure on 1 line. Well, I know there are these special power strips available. I don't have those. Then you can do it times 10 in a single one. I will try to show a picture. But I don't have that. So what I will do, I will just open the cable. Try not to cut in the little isolation, only in the outer. And then we just need to peel one out. Okay, I managed to cut through the isolation without damaging the wires itself. And then we need 1 only, so the rest can go back. And then we should be able to measure something if we just take 1 cable. Well, that doesn't look really nice, but I was able to close it, and then we can measure here in 1 wire, and then we should be able to get it through it, and then we should get the value. So fire up the setup again. Okay, well, we're just going to plug it in. Have this one here. Plug this in. Power on. And electronic load on. We have again 10 amps, almost 1 amp here. Do we see now something to measure? So 200 amps. Go through 1 wire only. And now it says 0.6. But it measures. And of course, it is on the 200 amp setting, so yeah, it will not be very precise. And also like this, it's even a little bit more, but this is far from ideal, of course. Let's try the other. And these things, they are designed for one-hand operation, and it actually is true, because you can do all with one hand. So let's see what this one thinks. Here it is better, it says 1, and it is 1. Yeah, I was thinking 1 amp is very low, but I'm on the secondary side there. I'm already above 10 amps. So I think I'm gonna take the secondary part out, and I will just do directly the load on the power supply, because this one can deliver 35 amps. So that means we should get 2 or 3 amps on the other side. And we just need to look on this side only. So we still come back to this 1 amp, but I can go higher. So if I go now to 20 amps, then we get 2 amps here. Can I go a lot far? I can go up to 40 amps. So let's see, 30. Now things start to blow. 30 amps. We are on the max here of this power supply. We are 3 amps here. So let's see what we measure. Now, I don't do it too long, because everything will start to blow. It says it's 2.1 amp. So it is not that precise at all. What about this one? I probably need that. This one says it's 3 amps. So the one with the true RMS is actually better. Yeah, 3 amps. 3.1. This one, let's try again. Because it was also low on the other setting. Nah, it is 2.1. 2.1 is not correct. But we are very, very low on the scale. But the true RMS meter, the 32, does that a lot better. I will switch it off because both my power supply and my cables are start to be a little bit warm. So the voltage setting on the 30 was better, and the current setting, what it is all about, is better on the 32. Both are second hand. So I think I want to open them and see if there are some possibilities to adjust. Okay, both are open, and we can see a slight difference already. And well, this is the 30, and this is not that full here. And here is one pot to adjust, and here we have at least two here. Here is one, and here is one. Oh, here also. So this is probably for the current, and this could be for the voltage. And then we have here the current and the voltage and something else. So we need to read which one is which, but it is very, very small. I don't even think I will touch it because these pots are so small. I will probably just break it when I use my screwdriver. I was looking at the pots and which one I maybe should adjust, and then I found out the problem also why the other one was not feeling that stable. If I push here, nothing moves, and that's good. And this little screw here, there's a very tiny screw there. Yes, there. And that was a little bit loose, and that made the whole thing here moving. I thought I need to tie this one, but that was not the case because that only makes this go. But here, and I will untie it again. The screws are very tiny, but if I click here, you can see everything moving. It gets off center. Look. And when I tighten the screw, it feels just as good. So that was an easy fix. Going back to the comparison, also the RMS is usually done with the RMS chip because it needs to calculate, and that one is here missing, and here we do see it. And now I wonder, because I think it was Fluke's own chip on the normal multimeters, so I wonder if it's the same here. So let's try. Well, this chip doesn't say Fluke, it just says BU4030. And this is maybe some sort of op amp, it doesn't say Fluke either. But maybe it's on the other side. Okay, well, I think there is only one little screw. Here are wires, so we need to be careful. But if I unscrew this one, you can probably take the whole board out. But all the wires are still connected. So, well, the wire from the buzzer seems kind of short, so it's all stuck. But if we look quickly underneath, let me see if I can put the light, then we don't see any chips on the bottom. So I will just leave that as it is. Just push it back in. I'm also afraid that this plastic will fall off and then the whole switch is not what it should be. So I will just put that back in. Well, it looks like those little pots don't have a little star like this inside, but some kind of a square thingy. And I'm looking through all my trim stuff, and I think I have one. No, I need a lot smaller. Okay, let's put it on a microscope. Maybe we can have a better look on the pot. Yeah, here it is. Oh, it's already focused. I thought that it was a square hole, but now I'm doubting. I think they probably have a tool that just turned the hole outside of this pot. Look, this is my screwdriver, and it is this little one. It is so tiny. So clearly I cannot do it, but maybe I need some kind of an oval tool that goes on top, and then it just grabs on this side here, and it grabs on that side there. So after the cleaning they look like this, a lot better. Well, the Serie already looked good and it didn't have too much movement, but the 32 did, and the 32 really has a better look now. Open, close. This is a lot less movement, and they feel now the same. So that was the 30 and the 32. Yeah, I could not adjust them because I just don't have the correct tools, but it is interesting because probably more of the Fluke meters will have these. So I think I want to look, or if you guys have a tip, maybe where I can find it. Or maybe there is an easy solution, you just need to put the screwdriver in, but it seems so small to me, and I think if you move too much you will just break the head off, so I didn't want to do that. But I feel better that they look a lot better, and yeah, maybe you could see, I don't necessarily feel it for these Clampmeters. That has nothing to do with this product because it looks amazing and it looks strong, and they say you can drop it from 2 meters, so that is not it. But I just don't use them, and I just play a little bit, and this one is 400 and 600 amps. I'm not going to use it, but I just wanted to show you because yeah, it is a Fluke, it is in the 30s, and next time we'll have the 37. I'm not sure it's next Friday, but it will be on a Friday, a Fluke Friday. Thank you for watching, and I hope to see you next time.